So just a few formulas that are going to get us through this whole thing. I have videos explaining why these formulas are true in other videos, but now we're just going to use them. So the sum of the interior angles is 180 times the number of sides minus 2. So all the interior angles added together would give you that. The sum of the exterior angles is 360, and if we add an interior angle and an exterior angle, we see that that's going to be 180. They make straight lines. So here they're asking us to find the measure of one interior angle. Couple ways of attacking this. I'm going to do the first three. Most people see interior angle and they say, oh, I'm going to use my sum of the interior angle formula. And so they pump that out and they go, okay, the sum is going to be 180 times the number of sides, in this case 5, minus 2. So 180 times 3 is 540. And that would give you the sum of all these guys added together. But they want just one of them. And they should have said that these are regular polygons, because in the case of regular polygons, all the sides, and in particular in this case all the angles, are the same. If they weren't all the same, we'd have no idea which each one of them were. They could have been a funky pentagon. But if they're all divided equally, if they're all the same, they're all divided equally, so we just take that 540 divided by 5, and we get that each angle is 72 degrees. So each one of these interior angles is 72 degrees. Check. Let's do it again. So this one here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. So the sum of the interior angles is going to be 180 times 11 minus 2. So 180 times 9 is 1620. So that's the sum of all of them. So take that 1620 and divide it up amongst the 11 sides that you have, and you'll get that each angle is 147.3 degrees. That's each one of these little guys in there. Awesome. We do it again. And this one there are 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So the sum of the interior angles is going to be 180 times 9 minus 2. So 180 times 7 is 1260. And then if we divide that 1260 equally amongst our 9 angles, we're going to get that each angle is 140 degrees. Check. So that's one way of finding one interior angle. Another way to do it is to actually go and get the exterior angle first, and I kind of like this. So if there are 360 degrees in all the exterior angles combined, then I have 1, 2, 3, 4, 5, 6, 7, 8. So if I just divide that 360 degrees by 8, I can figure out that 360 divided by 8, I know this is 45 degrees. So if each exterior angle is 45 degrees, then each interior angle must be supplementary to that. So each interior angle is just 180 minus 45 is 135 degrees. Cool. We do it again. So this guy, each exterior angle, take my 360 and divide it by the 6 angles that are in here. So each exterior angle is 60, which means that each interior angle is 120. Check. This guy, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. So each exterior angle is 360 divided by 12, which is 30. So each interior angle is supplementary to that. So each interior angle is 150. And so that's that. So I think, so your challenge now is to do these guys that way and these guys that way. And as long as you're familiar with those ideas, you can do anything. And I'll just do one more, the very last one. They ask us, is there a regular polygon with an interior angle sum of 9,000? So they're asking us about the interior angle sum, and we're like, yeah, we got a formula for that. The sum of the angles is supposed to be 180 times n minus 2. We'll just make this a nice plug and chug. The sum of the angles is 9,000. That's supposed to equal 180 times n minus 2. Just divide by 180, so 9,000 divided by 180 gives me 50. So 50 should equal n minus 2, and add the 2 over, so n equals 52. So yes, it works for a 52-sided polygon. Excellent.